The CAP theorem, also known as Brewer's theorem, is a fundamental concept in distributed systems. It states that it is impossible for a distributed data store to simultaneously provide consistency, availability, and partition tolerance. Consistency refers to the idea that all nodes in a distributed system see the same data at the same time. Availability means that every request made to the system receives a response, even in the presence of failures. Partition tolerance is the system's ability to continue operating even if there are network failures that cause communication between nodes to be unreliable. According to the CAP theorem, a distributed data store can only guarantee 2 out of the 3 properties: consistency, availability, and partition tolerance. This means that in the event of a network partition, where nodes are unable to communicate with each other, a distributed system must choose between maintaining consistency or availability. If consistency is chosen, the system will not be able to respond to requests until the partition is resolved and all nodes can agree on the state of the data. On the other hand, if availability is chosen, the system may respond to requests with potentially stale or conflicting data until the partition is resolved. The CAP theorem has significant implications for the design and implementation of distributed systems. It forces architects and developers to make trade-offs and carefully consider the requirements of their applications. Some systems prioritize consistency over availability, while others prioritize availability over consistency. Additionally, the CAP theorem highlights the importance of partition tolerance in distributed systems, as network partitions are a common occurrence in real-world environments. In conclusion, the CAP theorem states that a distributed data store cannot simultaneously provide consistency, availability, and partition tolerance. It is a fundamental concept in distributed systems that guides the design and implementation of these systems, forcing architects and developers to make trade-offs based on the specific requirements of their applications.